In this video, let us try to understand the term what is meant by a sinusoidal transfer function. As we know that in general, in control systems, we represent the transfer function as function of Laplace transform, and most of the times this transfer function is designated with the letter g of s. You know that s is a complex variable whose value is given by s is equal to sigma plus or minus j omega. Here the sigma refers to the damping factor or the damping ratio or damping of the system. If the sigma value is equal to 0, then the system will become undamped system. It means a system with 0 damping. Then the value of s will become s is equal to j omega. Now, if this omega is varied from a value 0 to infinity, then the values of s are also going to change from 0 to infinity. Now, if we replace the value of s in g of s with j omega, then this g of s will changes to g of j omega. So that as this value of omega is varying from 0 to infinity, the magnitude and the phase angle of g of j omega is going to change or vary. Then this g of j omega is known as a sinusoidal transfer function. So, a sinusoidal transfer function will have a magnitude and phase angle. In the coming lectures, I will explain how to evaluate the magnitude and phase angle of a particular sinusoidal transfer function.